Have you ever looked at yourself in the mirror and wondered if your reflection is just you or if it lives in an alternate universe where right is left and left is right? Well, do I have the topic for you. Stereochemistry. This is a concept in chemistry that allows us to view molecules as more than just reactants and products, but also as particles with personality. To understand more, we can also define stereochemistry as a study of how chemical compounds exist in space and their orientation. When thinking about this, we need to consider chirality. To be chiral means to have a non-superimposable mirror image. I have used model kits to illustrate. For example, if you place your palms side by side and try to place one on top of the other, your fingers and thumbs do not perfectly align, so we say that our palms are non-superimposable. But it's more than that with molecules. Some compounds have what is known as a chiral center. In simple terms, this is when you have 4 different functional groups attached to a carbon. Like the bromine in purple, hydroxyl in red, chlorine in blue, and hydrogen in white. The molecule on the left is chiral because it has 4 different functional groups attached to it. The one on the right is not chiral, or in other words, achiral, because it has 2 identical things, that is the hydrogens, attached to it. But hold up, some other compounds do not have chiral centers but have stereochemistry, like E and Z alkenes. Z meaning same side. That is when the functional groups with the greatest masses on either side of the double bond face the same direction. And E meaning opposite sides. That is when they face opposite directions. So, you discovered that you have stereochemistry. Now what? We now check for if you have family. Enantiomers, diastereomers, or constitutional isomers. When a compound has a non-superimposable mirror image, they are a pair of enantiomers, which is just Greek for opposite, like our palms. If we compare 2 compounds that are not even mirror images and are constitutionally the same, that is, they have the same connections, these are diastereomers, like disaster. But to truly decipher if a molecule is chiral or not, because some can be fishy, we have to check for something called symmetry. If a molecule seems chiral but on further inspection is not chiral, we call this meso. So, if a compound has a plane of symmetry, or if the distance around the shape from a certain functional group is the same, it is now achiral. What are the applications of stereochemistry? One of them is optical activity. Chiral compounds can rotate plain polarized light. Pretty cool, huh? By the way, when you have equal amount of a compound and its enantiomer, it is racemic. The spatial arrangement of molecules is important in the design of medicine like ketamine in anesthetic and oxybutynin used to treat urinary and bladder disorders. We also see stereochemistry in fragrances such as carbone. So now you know a little about stereochemistry, and when next you encounter a molecule, you'll hopefully see it for more than just another reactant. Thank you. I have also added my references in the description below.